Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Sum of digits of string after convert. In this problem, we are given a string S consisting of lowercase English letters and an integer k. Then first we convert S into an integer by replacing each character with its position in the alphabet. That is, replace A with 1, B with 2 and so on until Z with 26. Then transform the integer by replacing it with the sum of its digits. Then repeat the transform operation k times in total. For example, if S is equal to zbax and k is equal to 2, then the resulting integer will be 8. Let's see how. So initially we convert string into an integer by replacing each letter with its position in the alphabets. And we know that position of alphabets are A is 1, B is 2, C is 3 and so on. And then X is 24, Y is 25 and Z is 26, right? So we write Z as 26, B as 2, A as 1 and X is 24. So this is how we convert the string to a number and then we do the transformation. So by transformation, what they mean is like we have to do the sum of digits. And this will be transformation number 1 and sum of digits will be 10 plus 7, that is 17. Then we do the transformation number 2 and this time we again do the sum of digits and we'll get 1 plus 7 equal to 8. Now we are done with all the transformations. Now we have exhausted all the transformations. So we will get our answer is equal to 8. Now in terms of solution, the algorithm involves two steps. First, we convert a given string of lowercase letters to their respective positions in the alphabet. And how can we do that? So one way can be that we iterate on the string and then for each character, we can just do ch minus a plus 1. So suppose ch is a, then we can just do a minus a plus 1. So that will give us a equal to 1. Similarly, if ch is b, then we will do b minus a plus 1. That is 2 and so on. And what is ch minus a plus 1 actually doing? We know that the ASCII values of lowercase English letters ranges from 97 to 122. So b will be 98, c will be 99 and so on. And when we do ch minus a, what we are saying is, we are saying whatever is the ch value, suppose ch value is c, right? Then the corresponding ASCII value will be 99. Then we subtract character value a, so that will give us 97 plus 1, right? So this will give us 3, and that is the position of c in the alphabets. Instead of subtracting a, we can also do ch minus 97 plus 1. That will also work. So it's up to you. So now we have got the corresponding character position in the string. Then how did we convert this string to a number? We just concatenated these positions for each character in the string. And in Java, we can actually concatenate the strings using addition operator, or we can use the concat method, or use the append function in the string builder. Using the string addition operator or concat method will be expensive because Java strings are immutable. Please check out this video for more. So better thing is to use string builder implementation for mutable strings. So our step 1 is complete. We have converted the string to an intermediate numerical string. And now our step 2 is to transform this intermediate numeric string. That is, sum up all the digits and we have to do it k number of times. But do we have to transform the string k times in all the cases? And the answer is no. For example, let's take the same string zbax and now k equal to 3. So after performing two transformations, we got string 8. But now if we try to transform the string third time, because k is equal to 3, then we will get the 8 again, right? So once we touch single digit string, our string will not change and we can actually terminate early. Now let's jump into the code for more clarity. So our first step is to convert the lowercase character string to numeric string. And for that, we have to convert each character to its alphabet position and do the concatenation using the string builder. Now we will loop over the string character by character and get the position of the character in the alphabet. So it will be ch minus a plus 1. Then we will just append it to the numeric string builder. So our step 1 is now complete. Now our step 2 is to do the transformation k number of times, or till the number of digits in the numeric string becomes 1. So let's define our current string as numeric string, and now our transformation starts. So we will get transformed string back from, say, sum of digits function, and we will pass current string to it. And if we have obtained a single digit string, we can break out of the loop early. Otherwise, we can continue. And finally, because we have to return integer, so we will just do integer.parseInt and pass current string to it. Now let's define our sum of digits function. Because we are returning the transformed string, so it will return string at the end, and it will also take an input string. So initially sum of digits will be 0. Now we will go through the string character by character again and sum the digits. And because it's a numeric string, all the characters in it will be digits. So we don't have to check if character is a digit or not, right? So we can just say character dot get numeric value and convert that digit. Another way can be that we can also do whatever is the character, say digit minus 0. So that will also give us the numeric value. So if it's 0, we will get 0. If it's 1, we will get 1 minus 0. So again, we are doing the subtraction of the ASCII values for the digits 0 to 9. ASCII values for digits 0 to 9 is from 48 to 57. So we can also do digit minus 48, but it is up to you. I prefer using character.getNumericValue as it is more readable and bug-free, but it can be slower as it involves additional function call instead of simple arithmetic operation. And sometimes interviewers don't allow usage of internal function, so it is a handy technique to use. Now we will just return this integer as string so that we can do the sum of digits for the next time easily. That's it. And now let's run this code. Cool. Let's submit this code. Awesome. In terms of time complexity, it will be O of n into k, where n is the length of the string and k is the number of transformations we have to perform on the string. Because when we convert the string to numeric string, it can go up to the length of 2n, assuming each alphabet position is a 2-digit number, like 10 to 26, but it is still proportional to n, right? And after that, we perform k transformations on the string. And for that, we have to sum up the digits. So that again takes O of n time. And because we are doing it k times, it becomes O of n into k. And in terms of space complexity, it will be O of n, because after converting the string to numeric string, the maximum size it can go is 2n, right? So again, it is still proportional to O of n. I hope this video was useful to you. If it was, please like, share and subscribe. If you have any questions or suggestions, please feel free to write it in the comment box. Thank you for watching. I'll see you in the next video. Happy coding!